Welcome back, Algebra 2 fanatics. We're in lesson 79. We're going to talk a little bit about metric volume. All right, so remember when we did conversion on meters, cubic meters, right? And we started to learn how to use the cube or the exponent. So we learned that we could just write, let's say we wanted to turn that into, let's just say we were doing inches, cubic inches. We learned that we could do this right here. And we could do, let's see, what's our unit of reference here? We have 1 inch is equal to 2.54 centimeters. And 100 centimeters was equal to 1 meter. We learned that if we cubed all of these units individually, that we didn't have to write it out, right? So we learned that we could say, okay, well then that means 100 cubed times centimeters cubed is equal to 1 cubed meter cubed, which allowed us to cancel out the meters cubed. And then we could turn around and we could put in 1 cubed inch cubed is equal to 2.54 cubed centimeters cubed. And that would allow us to cancel out the cubic centimeters. And we ended up having 7 times 100 cubed over 2.54 cubed inches cubed, because that was our final unit of measure, right? Which is the same thing as if we had done it out long ways. And long ways was where we would say 7 meters over 1 times 100 centimeters over 1 meter, cancel. 100 centimeters over 1 meter, cancel, times 100 centimeters over 1 meter, cancel. You get the idea. This is the same thing as 100 cubed centimeters cubed, right down here. And we would have had to have continued on in writing this, saying 1 inch over 2.54 centimeters, cancel, times 1 inch over 2.54 centimeters, cancel, times 1 inch over 2.54 centimeters, cancel, 1, 2, 3 inches, right? So that would have been the same exact thing. We just wrote it a little bit faster, a little bit more succinctly. We're doing the same thing, only this time, instead of cubic meters, we're using milliliters. And we're going to use the metric system. So let me clear this page for us. See, this is shifted. Let me move it over a bit. Let me clear the page. Here's our first problem. And we're given a new unit of reference here. And the unit of reference that we have that you need to put in the back of your notebook is that 1 liter is equal to 1,000 cubic centimeters. That's what 1 liter is. Okay? So we could say that in the reverse, because this is 1,000 and milli means 1,000, we could say that 1 cubic centimeter is equal to, or is the same as, 1 milliliter. 1 milliliter is volume. Liter is their unit of measure in the metric system for volume. So it doesn't get cubed. How interesting is that? All right, so we're going to use unit multiplier to convert 14,000 milliliters to liters. All right, now in relationship liters to liters, we know, or I will tell you if you don't know, that 1 liter is 1,000 milliliters, which makes sense because a liter and milliliter, it would take 1,000 milli equals 1,000. That's what it means. So here's what we do. We bring this down. We write 14,000 milliliters over 1 times, we want to turn this into liters, so we put liters on top, 1 liter, and then 1,000 milliliters on the bottom. Cancel out milliliters. So that equals 14,000 over 1,000 liters. Now, I have always said in algebra just to leave the improper fraction, to leave it like this. However, in the metric system, it is so easy to perform calculations because they're all base 10. When you have a fraction that is so easily reducible like this, it divides into a whole number. Obviously, go ahead and reduce it. That's 14 liters. Because the zeros cancel, 14 over 1 is 14. So our answer is going to be 14 liters. So when it's that easy to reduce, go ahead and reduce it. All right, I've always said that anyway. If your fraction is reducible, go ahead and reduce it. So this one is reducible and divisible. So we're going to go ahead and do the division. All right, that was 79.1. We're going to do 79.2. It's actually pretty straightforward, but I'm going to do it on another page anyway. Pause if you need to. I'm going to clear the page. All right, 79.2. We're going to convert 4 cubic feet to liters. So we're going to need some points of reference here. And that point of reference is that 1 liter is 1,000 centimeters cubed, right? So we also need to know the conversion from feet to centimeters. So it's going to go for feet. 1 foot is 12 inches, and 1 inch is 2.54 centimeters. So pay attention when we get to centimeters, okay? Because this is in centimeters cubed. So 4 feet cubed over 1 times, now we're going to go from feet to inches, so 12 cubed inches cubed over 1 cubed foot cubed. So we can cancel out feet cubed. Times, now we're in inches, we're going to go to centimeters. So this is going to be 2.54 cubed centimeters cubed all over 1 cubed inch cubed. Inch cubes cancels. Times, now we're going to use our liters, 1 liter over 1,000 centimeters cubed. Notice we didn't cube this because 1,000 centimeters cubed is 1 liter. So this cancels this without having to worry about cubing anything else. So our answer is going to be 4 times 12 cubed times 2.54 cubed over 1,000 liters. That is the answer. All right, let's do one more of these, and I'm going to leave our points of reference up here just in case we need them. This is 79.3. And we are going to convert 4.7 liters to cubic inches. All right, so 4.7 liters over 1. So the first thing we're going to do is we're going to convert this to 1,000 cubic centimeters over 1 liter. All right, so this cancels out this. Now we're going to do centimeters to inches. So this is 1 cubed inches cubed over 2.54 cubed centimeters cubed. Centimeters cubed cancel centimeters cubed. So this is going to equal 4.7 times 1,000 over 2.54 cubed inches cubed. All right, that will be our answer. So the tricky part is to remember that liters and liters is already centimeters cubed, and to go from here to doing this the right way, and remembering to cube our centimeters and our inches when we make that shift from liters to centimeters. All right, and that is all the conversion in metric volume that we're going to do. Let's move on to 45, 45, 90 triangles. If you remember, we've recently done the 60, 30, 90 triangles, and this was 1, 2, these are the dimensions of a 60, 30, 90. 1, 2, square root of 3. And that, so if you have a right triangle with a 60 degree or a 30 degree measure, you can use the scale factor system in order to find the other side lengths of that similar triangle. So we're going to do the same thing with a 45, 45. And a 45, 45 looks like this. It's just a little bit different from this one. So 45 here, 45 here. So both of these. So that tells us that this side is going to be the same as this side, because that's an isosceles triangle, because we know that when these two sides are the same length for an isosceles, that these two angles are also the same angle. So if they're 45 degrees and 45 degrees, it's an isosceles triangle. So that tells me that whatever this side is going to be. So in this type of a triangle where the degree of measure is 45, this side is 1, this side is 1, and this side is the square root of 2. So these are your base measurements for an isosceles triangle where both of these congruent angles are 45 degrees. All right, that's your unit of reference. So let's do a practice problem. Let's do 79.4 using this information. So let's clear this. We have a isosceles triangle here. Let me see if I can draw it out pretty close. That's not too shabby. This degree of angle is 45. This is 90. So that tells me right away that this is 45 degrees, right? It also tells me that this and this are the same length. And I'm going to just adjust this because it doesn't look exactly right to me. There we go. That looks a little bit better. That looks a little bit more like they're the same length. The measure of this is x, and the measure of this is y, and the measure of this is 7. So knowing what I know about an isosceles triangle that has the congruent angles at 45 degrees, I know that x is going to equal y because they're congruent. I also know that this ratio is going to be, that's going to be the same as 1, that's going to be the same as 1, and this is going to be the same as the square root of 2. That is the relationship all the way around. So 7, or I should say the square root of 2 times some scale factor equals 7. That's how we got to here. We multiplied this times some scale factor to get here. So I am going to divide both sides by the square root of 2. And I get a scale factor is equal to 7 over the square root of 2. We don't like having the square root of 2. So we're going to say times square root of 2 times square root of 2 like we always do. And we're going to say the 7 times the square root of 2 over 2. That is our scale factor, right? That is our, that is what happened. That's how we got there. Now we can find x and y because we can multiply this times 1 to get x and y. So therefore, 7 times the square root of 2 over 2 times 1 is equal to x and y because x and y both equal 1. So this times this is 7 times the square root of 2 over 2. So this is the value of x and y. Easy peasy. All right. You just take this square root of 2 times the scale factor and have it equal the new dimension for the hypotenuse. Or here on the y factor, whatever it is, whichever side it is that you have access to, you multiply that times some scale factor to get the new dimension and then divide if you have to, and that's going to be your new scale factor, just like we did here. All right, that is all we have for lesson 79. I will see you in lesson 80. Guess what? Lesson 80 is 2/3 of the book. Y'all are moving on. Congratulations.